All right, so that's what happens here. Okay, so the square root and squaring basically go in opposite directions, so to say, if the number is non-negative to start with. Okay. Good. Okay, so that's one important property. Another one, though, is this. For any two non-negative real numbers, the square root of a product is the product of the square roots. So the square root of a product is the product of the square roots. It's compatible with multiplication. Same thing with division, except you need the denominator to be strictly positive, the radicand that is, because you don't want to have 0 in the denominator. So we have those properties, and I'm just demonstrating the first one with 25 and 16. You know, we saw that the square root of 25 is 5. I think we actually saw that. Square root of 16 is 4. So this product here is 5 times 4, which is 20, but also the square root of 25 times 16. That's equal to the square root of 400. That's what this is equal to. So, and that turns out to be 20. So 25 times 16, that's 400. So the square root of this, then is the square root of 400, which is 20. 20 is non-negative, and 20 squared is 400. But if you compare these two, you would see that these two are equal. You know, they both equal to 20. So, I mean, that's not proving this property, of course, but it's just illustrating it. I think it would just follow from the definition as to why it's true. All right. Are there any questions so far? Okay. Now that's what square roots. Now we can get into the notion of simplifying square roots. And to really understand that, we need to understand the notion of perfect squares. Perfect squares, they're going to be numbers of this form, m squared, where m is a natural number. Excuse me. Remember, a natural number, by definition, is just a positive integer. A natural number is a positive integer. So in other words, perfect squares are numbers of this form where m could be any positive integer. So here's some perfect squares. We have 1 squared, which is just 1. So 1 is a perfect square. 2 squared, m here is 2. So that's 4. 4 is a perfect square. 3 squared is 9. So 9 is a perfect square. And so on and so forth. Of course, there would be infinitely many, since there are infinitely many m here, possibilities for m. So these are the perfect squares. Okay, now why does that come into play? Well, by definition, a square root is said to be simplified if the radicand has no factors that are perfect squares except 1. Notice I did not say 0. 0 is not a natural number here, so 0, 0 squared, that's not a perfect square. 1 is always a perfect square, and 1 is a factor of everything. So for a square root to be simplified, the radicand cannot have any factors that are perfect squares besides 1. As an example of that, let's look at these numbers, the square root of 15. Well, the factors of 15, right? We know 15 is 3 times 5, so it's 1, 3, 5, and 15. And that's it. Going back to the list, 1 is in here, and that's a perfect square. We can see that 3 and 5 are not perfect squares. Remember, you want to look at the bottom row. So 3 and 5 are not down here, so 3 and 5 are not perfect squares. And neither is 15, as we can see. So this is simplified. So this is simplified. Good. All right. All right. What about 20? Square root of 20. Well, what are the factors of 20? You have to look at the factors, right? We have 1, 2, 4, 5, 10, and 20. I don't think I missed anything. But 4 is a perfect square, right? 4 is 2 squared. So 4 is in this form. So 4 is a perfect square. So this is not simplified. Square root of 20. Square root of 45, same idea. If we look at the factors here, we have 9 as a factor, and 9 is a perfect side. 9 is a perfect square. 9 is 3 squared. So this is not simplified. So again, to be simplified, the radicand, what you're taking the square root of, the only factors of it, that's a perfect, it's simplified if its only factors that are perfect squares is 1. Okay, sorry, I don't want to go too fast. All right. Okay, so that's what it means to be simplified. But if you have something like this, we can wonder, how do we simplify it? Well, that's the next slide. How do we simplify it? So essentially what you want to do is this. You want to find a perfect square besides 1 that's a factor of the radicand. You want to find a factor of the radicand that is a perfect square besides 1. I mean, if there isn't one, then it's simplified already. But if there is one, then we can simplify it. You're going to factor it out, essentially. You're going to apply this rule. And then you repeat the above on the remaining square root. You know, if you have to, you may not have to, but it's possible that you might. So essentially, you find that factor, you factor it out, you use this property, and then repeat on the remaining square root. And that's what it means to be simplified. Well, excuse me, that's what it means to simplify. My mistake. Let's try it out. As an example, here's the square root of 20. We already know it's not simplified, right? Because 4 is a factor of 20. And 4 is a perfect square. Okay, so that's great. What do? Well, let's factor it out. Remember, to factor it out, you have to divide to see what's left over. I mean, here it's actually it's not too bad because 20 is not that bad a number. But when you factor out 4, what you're left with is 5. 20 over 4, which is 5. Like so. Okay. Then, so we have 20 is 4 times 5. Now we go back to this property here. So the square root of 20, right, is the square root of 4 times 5. And using that property, we get the square root of 4 times the square root of 5. But the square root of 4 is 2. Okay, we know 2 squared is 4, and 2 is non-negative. So the square root of 4 is 2. So what we have then, simplified, is this. Actually, I got ahead of myself. But we get this, though. But now is this simplified? Square root of 5. Well, what are the factors of 5? The factors of 5 are just 1 and 5 alone, right? And only 1 is a perfect square. We can see that 5 is not on the list. 5 didn't make the list, so to say. Okay? So 5 itself is not a perfect square. 1 is. So the square root of 5 then has to be simplified. So in other words, we're going to get this. Simplifying it, we get this wonderful thing. You can't break it down any further, is what I'm saying. I mean, 1 is always going to be a factor, but you want to know if 1 is the only factor that's a perfect square. Okay. Let's do another one. Are there any questions, though, about this example? Okay. We do another one. Let me do the video.